welcome to episode 21, the Gaseous Planets. And good afternoon, Shane. You're going to have some editing ahead of you.
Oh, that's easy.
So I'm not sure how much of our preamble discussion that I picked up there, but it could be a significant portion of it. So how's your day going?
Good. You know, it's funny. We have winds of 30, I think 30 or 40 kilometers per hour, gusting to 50.
Oh,
And
it's
it seems
dropped
like a
then.
peaceful day.
Yeah, exactly. Exactly. Last night I woke up and it was like somebody had like a series of fire hoses aimed at the back of our house. And then some giant creature was just scratching claws on the stucco all around our bedroom. And then like I slept maybe 2.5 or 3 hours. And my wife, she just like slept like a baby right through the whole thing. And so I'm a little bit tired today, but hopefully tonight get some good rest. So this is part two to episode 15. Wow, hard to believe we're on episode 21 now, but this is the second part to the one that we did several weeks ago now on the terrestrial planets, which were Mercury and Venus, Earth, of course, though we didn't really talk that much about Earth, and Mars. But what are these? What are the four gaseous planets? I guess is what we're calling them now.
Yeah, so they're much larger than the planets we talked about in episode 15, and they are Jupiter, Saturn, Uranus, and Neptune. Um, there's a lot of interesting features to observe there, and I guess we'll probably get into it here as we go on through the episode.
Yeah, so the one thing that has changed, at least since I've been doing astronomy anyway, is we used to refer to the four of them as the gas giants, but that's changed now because the term gas giant was coined in 1952, which is long before you and I came around. But now they refer to the gas giants as just the planets like Jupiter and Saturn, and then planets like Uranus and Neptune. Technically, we're referring to those as ice giants. And I suppose because the gas giants are giant planets composed mostly of hydrogen and helium, and a layer of metallic hydrogen makes up the bulk of each planet. But the ice giants, they have, water clouds and, other type of clouds that are more ice related, like ammonia and some non-hydrogen clouds. I think methane clouds as well. So anyhow, so we'll start with Jupiter. How does that sound?
Love it.
Might as well, since we're working our way from the inside out. So the king of the solar system. So what do you know about Jupiter, Shane?
I know it's my favorite planet to observe in
Really?
the
Why is that?
whole solar system. It's the most dynamic. You have the 4 Galilean moons. So there are very large moons in the solar system. They're visible through, good, powerful binoculars, but through any telescope, you'll see the 4 moons.
Yeah.
They're always in different positions, different alignments. You don't see any of the, well, maybe with a really big telescope, you'd see some surface details, but for your typical backyard telescope, they really just look like stars. But they're always moving. If you time it just right, you might capture one coming from behind Jupiter, or passing, like going from being visible to going behind it, which is a really neat thing to observe. I think a couple episodes ago we talked about the shadows, shadow transits. So that's really neat. There's a number of different bands on Jupiter, cloud bands, that all have unique detail. And what's really neat is I think their rotational period is like 9 hours.
9 hours, yeah, is like the median time. Of course, clouds at the equator and clouds at the North Pole might move at some sort of variance. But just 9 hours for them to rotate around. So you can see a lot of different things over the course even of an evening.
Absolutely. And, probably the showpiece feature is the Great Red Spot. It's not always visible, but when it comes around, I love looking at it. You can see so much detail. Now, you do need a good night of seeing, but you can see festoons, different kind of creamy to, brownish chocolatey colors in some of those cloud bands. Again, that Great Red Spot has kind of more of a pinkish tone, in my opinion.
Yeah.
But it's color. And again, it's always changing, and I love looking at Jupiter. And it's big, right? It's big, so you're able to actually get out a lot of the detail, and you can do that with like a, even a 60 millimeter telescope will show you a lot of things on Jupiter. You don't need a lot of aperture to have fun with that planet.
Yeah, it's got apparently, like in sort of my research for the podcast, and thanks so much for like that introduction on observing Jupiter. 2.5 times all the material of the other planets are in Jupiter, so it's really big. So big, in fact, that sometimes it'll be referred to as a failed star, and you could fit about 11 Earths across the disk of Jupiter, sort of. That's how big it is. And sort of for scale, you could only fit 10 Jupiters across the disk of the sun, sort of, so to speak. So it's really on just a huge order of magnitude larger than Earth and most of the other planets. And the neat thing about Jupiter is it spends about a year in each of the zodiacal constellations, plus Ophiuchus, and so that means that it's got about a 12-year orbit, and sort of some years it spends more time in a constellation. Some of the other constellations are pretty small. Now, you talked about some of the stuff that's observable. There's some really neat stuff that's not observable, like the aurora, the rings. There's about 80 other moons than the Galilean moons, and the radiation belts. So the moons, can you name the moons?
All 80 of them? Sure. Here we
No.
go.
Okay, we'll start with just the first four, and then maybe we'll give you a break after that.
Okay, fair enough. So the main moons, the Galilean moons. Why are they Galilean moons, Chris? What does that mean?
So they're called Galilean moons because Galileo discovered them in 1609, 1610, and Galileo was observing Jupiter and saw these bright stars around it, and then he sketched them, and very, very basic sketching, which really I find inspirational because I feel like I can actually sketch maybe a little bit better than Galileo did. And he just drew these little star like points around it, and then came back and noticed that over the course of several nights that they had moved. So they're named Galilean moons after Galileo, these four bright ones.
Yeah. So the names of these four moons, it's Io, Europa, Ganymede, and Callisto. And do you have a favorite?
I like Io because it just looks so strange and surreal. It looks like if you were going to invent a planet for like the original Star Trek cast to beam down on, it would be Io because it's covered in this yellow sulfuric material, and it's got all these volcanoes on them, and some of them are spewing out some red material over top of it. It just looks like it's just the wildest psychedelic colors. And when you're talking about color, and although we don't see any of these colors from Earth, just knowing that's out there, and waiting for such explorers and exploration really makes me excited. Like, it seems like an actual place, sort of second only to Mars for some pretty incredible detail. How about yourself? Do you have a favorite planet?
My favorite Galilean moon is Europa. And why I like that one is it's basically like a moon that's completely covered in water,
Mm-hmm.
but it has an ice shell around it.
Yeah.
And photos of it have shown that it's very dynamic. That
Okay.
these ice, I don't know what you'd call them, ice fields, ice plates. I'm not sure, but they're changing. Probably due to some gravitational effects of Jupiter. But they also believe, I think, that there's some volcanic activity underneath these ice sheets.
Mm-hmm.
But what really intrigues me about this is, if you have water, that's one of the key building blocks for life.
Yeah.
So in our quest to find life in the solar system outside of our planet, Europa is very, very intriguing. And, I don't know. I should have looked before this episode, but I know NASA was looking at some potential probes that would kind of
Drill down.
smash through, or drill down through that ice to start to see what's underneath there. Is it water like what we have? Is it what's the composition of it? Can anything be detected there? So it's pretty cool. I'm really intrigued by that.
Yeah, cool. So how about these other and sorry, I'm calling them planets because sort of in my mind, I'm not one of those people that believes that we should just have the eight planets. Although, personally, my personal view is that they've limited to eight so that it's still easy for some people to get their heads around them or something. But I really feel like these moons of Jupiter are so big, being larger, except for Europa, than our moon. And really, in many ways, I think that our moon is very much a planet of its own right as well. Um, but they have so much variance, and they just look like worlds, right? Having oceans, having active volcanism, active plate tectonics, others with oceans. I mean, these seem like planets to me, right? They don't seem like these moons. When I think of a moon, I think of kind of like a body that has no atmosphere, that's just cratered, and it's pretty static and sort of a boring place to go. And these are far from that, eh?
That's a great point. Yeah, especially Io and Europa.
Mhm.
They are very active. When we look at our moon, it is kind of dead. It doesn't really change. It had a period of volcanic activity and a lot of meteors smashing into it, changing the topography.
Yeah, billions of
But
years ago, though. But
yeah, like now it really doesn't change. So some of these other moons that we'll talk about aren't like that, which is kind of neat.
yeah. So we have Ganymede. That's a pretty big one, larger than our moon, covered in rock, and it also has uh, an ocean. I think it's like hundreds of kilometers towards the interior, but it's got some sort of water body in it anyway. And then we have Callisto, which is really big, but more similar to our rocky moon.
Yeah. And then the other 80 moons are much, much smaller. In some cases, I think they're almost just captured asteroids, aren't they? Like very irregular shaped, but they
Yeah,
just happen to orbit around Jupiter, so they get the moon tagging, and that a little less interesting in my opinion.
yeah. Well, even like so, the fifth moon is Amalthea, which I know because I'm a big reader of E. Barnard, the famous American astronomer, and he was the one that discovered it in the 1890s, and it was the last object that was discovered, like a moon around another planet visually. Um, and when they finally did imaging of it, like, it just looks like a little asteroid, and it's so much smaller than the others. You need basically something like the Lick 36-inch refractor to hunt that down. Just about. It's pretty faint. I know somebody who did it with a pretty big Dobsonian, but that's kind of what you're looking at.
Yeah, very interesting.
So you talked earlier about the bands and the belts a little bit. So there's some dark areas, and they're separated by lighter hued zones. And on poor to average nights of seeing, you can typically see what, like, two main dark belts, and then like the equatorial zone, that's the white zone that's in the middle, or the light colored zone. And then on excellent nights, how many belts or bands have you seen on really good nights, Shane?
Oh, gee, I think about 8 or 9. Like
Yeah.
the polar banding or whatever. It looks like one big section, and then like there's the equatorial bands. Um, yeah, 7 or 8 for sure. Maybe even probably about 8. I think.
Yeah, it's one of those things where it seems like you can see a lot of belts and bands on it on really good nights, and then it's kind of one of those things where some of them, excuse me, appear just below the visual detection level as well. So yeah, and that's sort of the main feature on Jupiter. And then, of course, we have that great red spot that you mentioned before as well, which is a giant anticyclonic storm. It's a large oval that rotates counterclockwise, taking about 6 days. And it's larger than the Earth. And possibly it's been observed since 1665, although there wasn't like active monitoring for many decades at a time. So it's hard to determine if that's what was originally visible there. But there's been a variety of other white and red ovals. I remember there was oval B8, that one that I think Chris Go discovered. Do you recall that one?
I do. Yep. Yep.
And were you able to observe that? Have you observed that?
I think I did. I'd have to go check my observing logs. I'm pretty sure I did.
Yeah,
Yeah.
I've
The
definitely seen that. So
and the Great Red Spot is kind of interesting because the I guess the deepness of the red kind of varies throughout history. There's been times where the reports have been that it's extremely red. And then even just a couple years ago, there was sort of speculation that it might just disappear altogether because it was getting lighter and lighter in color and even shrinking a bit in size. So, again, just to talk about the dynamic aspects of the planet, even the Great Red Spot varies, over time, and sometimes it's not like decades. Sometimes it's months. That you can see some real change there.
yeah, the one observation, like sometimes it can be hard to even pull out the red spot depending on the seeing conditions. Like I don't know, maybe it's easier for you or other people than it is for me. But there's often nights where I go out and look, and I'm like, is that the red spot? Am I actually seeing it? What am I looking at here? But then other nights it really seems to stick out. I don't know what your experience is like with that.
Yeah, Jupiter certainly is a very good object in the sky to determine how good the seeing is. Um, I've had some nights, and there's only been, I think, two or three of these nights when I've been looking at Jupiter where I can throw as much magnification in my telescope as possible and still have an incredible view of Jupiter. It almost looks picturesque,
Hmm.
and the detail is so incredible. But then on a night of poor seeing, yeah, sometimes the Great Red Spot can be really difficult to pull out, and sometimes you can't. Sometimes it's just, a challenge to pull out the banding almost.
Yeah. So the best you ever had it at was we had a 17.5 inch reflector at the Halifax Center when I was a member there. And we would mask it down to 14 inches. And we were looking at it when it was masked to 14 inches. And we could really see like detail in the red spot and then like sort of in that adjacent zone between the red spot and the belt that it kind of resides. You can almost sense like that cloud material kind of shearing against one another. And we were looking at, I think we had a light pollution filter that we were actually using for whatever reason. It gave a really eerie kind of greenish, iridescent green view to it. And the one thing that always stuck with me, just uh, in the way that we could see the clouds kind of just sort of sifting and moving, it reminded me of like almost like a cross section of like anatomy or something, and like the pulsing of blood through veins. It seemed very organic to me anyway, and that always really stuck with me. How much detail, and then how real it looked. Like it looked like a living thing, I guess maybe is the best way to put it. And that's something that doesn't seem to translate as well in photographs or anything else. Like how real these things look to your eye in real time versus in some sort of gussied up digital mediated Photoshop technology, eh?
That's a great point, and that's one of the reasons why I love visual astronomy is you really get a different sense of an object when you're looking at it with your eye. And it's not to take away from the photographs because they're great to look
No, they
at
are
too,
great.
but it is just a different experience at the eyepiece. And maybe one of the takeaways here for anybody listening is if you happen to be observing Jupiter and it's one of those nights where you can just keep putting magnification on and the view is great, don't stop. Spend your whole night looking at Jupiter.
Yeah.
Don't go to bed. Take it in because those nights are rare and incredible.
Yeah, and you can just kind of look for a while and then take a break, and you shouldn't look for real long stretches at any given time either, because your eye will get fatigued and it's not as enjoyable. But
Yeah, good point.
yeah, I always think of visual observing is kind of like going to the Louvre. I went to the Louvre. I referenced my trip to France at the end of the last podcast, and when I went, this is just about a decade ago, and everybody's got their digital cameras, and some people are even using their phones to take photos of everything. And you get there and you realize, like, well, everything, you can actually go online to the Louvre first of all, and you can pretty much go down the corridors and you can look at high resolution images of everything, pretty much, more or less.
Yep.
Same with a lot of other museums these days, which is really cool, especially during these times of isolation. But it's really surprising how many people still bother to get in that plane and fly over there and actually go to the Louvre every day. Like, it's kind of a funny thing in a way to think that everything can be consumed in this digital format, more or less. Yet still people will go to be in the presence of the original article. And of course, I don't know, have you seen the Mona Lisa before?
No, I've never been to the Louvre.
So the first thing people always say is, it's so small, right? Like,
Hmm.
and I'm not saying that as a negative thing. It's the size that it is, and it's a masterful work. I'm not really an art scholar or anything like that, but certainly I think argumentatively it would be one of the most well-known, if not argumentatively one of the best paintings ever created. So it's just kind of interesting to go and stand in the presence of the actual item, because there's something to do with the photons. My friend Tim would always say, when you're looking at a galaxy, those photons that were created those millions of years ago, they're traveling through space, and then they're actually interacting with your eye, and that this does something, like, in a way, although it's not like a real physical connection, but it's not that far away from a physical connection. Like, you're really interacting with it in a way, like you're actually interacting with the original article in a way, unlike an image which is taken and then you're just interacting with the photons that are being generated in that room. And it's the same. And I think that's why people go, whether they realize it or not. I think that's why so many people go and stand in front of the Mona Lisa, not just to say, oh, wow, it's so small. But I mean, that is part of it, is you actually get that sense of, well, how big are these pieces of work? And then some other things like, Venus de Milo, it's a pretty big statue. Like, I mean, like, when you stand there, you're like, whoa, like, and the tribute to Galileo is huge, like, I really hope Galileo wasn't that big. But when you actually stand in the presence of the actual article, I really think there is something to that. Sorry for the tangent. We should move on to Saturn.
let's let's do it.
Yeah, good stuff. So Saturn is the sixth planet from the sun. So what of Saturn, Shane?
What of Saturn? Well, this was my very first view through a telescope was Saturn.
Hmm.
And I would have been 10 or 11 years old. My mom and my grandpa took me to the local astronomy club. They had a public night, and they had a 4-inch brochure refractor, very old, made of brass. And they had Saturn in there, and I couldn't believe what I saw. And this image, so, I'm 43 now, so this was quite a while ago. And asked me what I ate for breakfast 3 days ago, and I have no idea.
Yeah.
But this image is still burned into my mind. It was so incredible. You see this creamy ball, the disk, or the actual planet of Saturn. And then you see these glorious rings surrounding it. And I thought that they were tricking me. I thought for sure they had just cut a picture out of a magazine and taped it to the end of the tube, because I just didn't think that you would see something like that. I don't know what I expected, to be honest. I was just blown away by that image. And, you and I do a lot of public outreach every year,
Yeah.
probably not this year because of the pandemic,
Mm.
but, hundreds of people will look through our telescopes throughout the year.
Yeah.
And when Saturn's in the sky, we make sure we show them that. And what's interesting to me is the reaction that I just described of what I had. I see that same reaction from many other people
Yeah.
when they look through my telescope and see Saturn for the first time. And in some cases, it's the first time they've looked through a telescope too in their lifetime.
Yeah.
And the emotional response that some people have is incredible, and it's an amazing thing to look at.
Yeah, it's one of those rare things in the nighttime sky that, unlike a galaxy or a deep sky object like a nebula or a cluster or something like that, or maybe even some other things, it's one of like the few things that it looks like what you're expecting, like in this very surreal way. Plus, at least to my eye, it seems to have this amazing three-dimensional aspect to it, where it really seems to be, you get a sense that it is floating out there in space, and it is this huge thing, because you're looking through this telescope, you know it's magnifying, and you actually get a sense of that again versus just seeing this flat image. And that's the thing, that I've taken away from the experience, is that that's what I think really impacts people, is how three-dimensional it actually looks. Like there really is depth to it. You get a sense of those rings cutting around the backside of it, that the rings that are tilted closer to you, they're reflecting light in a slightly different way than the backside of the rings. So it is just amazing.
Yeah, it's great to look at. I spend. It's interesting because outside of some basic detail within the rings and a little bit in the cloud banding, there's not a lot of like things to look at on Saturn. It doesn't change the way Jupiter does.
No.
It's not feature rich like our moon or even Mars for that case.
Yeah.
But I still look at it every night that it's up because it's so incredible.
Yeah.
I love it. What else was I going to say?
Well,
Anyway,
I'll jump in while you think on that, and I'll say
yeah.
that it does have bands and zones, like you referenced, in a way similar to Jupiter. They're just much more subtle and wider as you get near the equator. And it does have some storms. Like I can't remember
Mhm.
when it was. I feel like it was 2011 or 2012. But there was that great dragon storm about anyway, close to a decade ago now, I guess.
Yeah,
Do you
yeah, I
remember?
remember that.
I
I
think
never saw it,
I
but
think I
I remember it.
tried to see it. It was pretty subtle, but there's some great like Hubble and other photos of it. You'll get white ovals from time to time. I've seen the odd white oval on it under really good conditions, and it's got a huge polar vortex on each of the poles. The one in the north is a big hexagon polar vortex, like a big storm up there, and then there's a circular one on the south.
Yeah, have you ever seen those?
No,
Yeah,
I've never seen those. I think some people say like when it's tilted a certain way, they can
yeah,
kind of see the shading. But of course, because we're looking at it more or less like edge on, we're not flying up over the poles like they did with the Cassini spacecraft. That was the most recent mission there. But there's several moons, just like with Jupiter, we have a handful of moons there. Do you want to tell us a little bit about the moons of Saturn?
yeah. So there's a number of them that are visible just with a telescope. Again, they really just look like stars.
Yeah,
One of them is the largest moon, and I think it's the largest moon in the solar system, Titan.
sure, we'll go with
And
that.
that one is what's that?
We'll go with that.
Okay. Um, it's visible any night that it's not behind Saturn.
Yeah,
Rhea is often visible. I'm just trying to think of the other ones here.
Dione,
Tethys, I think, is often visible.
yeah,
Um,
Mimas,
yeah, yeah, yeah.
Enceladus, which is probably one of the most interesting moons in the solar system, because it's the one that has those geysers that are spouting off material, and I believe, I'm not sure if the theory has sort of held water or not, but I believe that the what do you call it? The hypothesis was that material is probably helping keep those rings alive, so to speak.
Hmm.
Now, how do you
Yeah.
see it? That I always want to call it enchiladas, and I always think I like enchiladas. So,
Oh, yeah.
and then Iapetus. So I think it's what, 2, 4, 6, 7. Yeah, you can see all these. So you can see Dione, Tethys, Mimas, Enceladus, Rhea, Titan, Iapetus. You know, good conditions, good telescope, medium-sized telescope. You should be able to see them all. But typically, like you say, on decent nights when it's visible, Titan is the one that's the most readily apparent.
Which moon is the one that has like the giant sort of fissure almost around it? Half of it is like very black, and then the other half of it is
Oh,
a much lighter color.
I can't recall.
Yeah, it's not visible through a telescope,
No.
but
I don't know. Yeah.
it's a very interesting planet because they think it was two bodies that collided. Is it Iapetus? It doesn't matter, but uh,
I think you can. Wait, I think what you do see though, just off the top of my head, I think what you see is that sometimes you can see it like through my 5-inch. I think sometimes I can see it, and sometimes I can't see it. I think because of it's so dark on one side. But I thought it was, now there's a couple. One of them is an object that was like two objects that were smushed together, and then one of them is like spouting out material, and then that material is falling back and covering one side in ice, and the other side is in this like dusty coal type colored material. But I'm not sure, are those the same object or not? Well,
Yeah, I think it is Iapetus. I'm just looking again on Wikipedia, and there's this equatorial ridge that goes around
okay. So
Iapetus.
there's
And
a ridge around it, eh? Hmm.
yeah, and there is like kind of a dark area that, yeah, it looks like it was dusted in coal almost.
Okay, so it's one object. Yeah, yeah. I thought that, what's the one that looks like the Death Star? Is
Oh,
that
that's
Mimas?
Mimas,
Yeah.
yes.
Okay.
And that crater is called Herschel,
Oh, okay. Yeah, I was kind of getting them, kind of getting those two mixed up. So
because
anyway.
William Herschel discovered the moon.
Oh, did he
So
really?
yeah, I'm
Wow.
just reading that too.
Oh, cool. Oh, it's, yeah, right off, as reliable as Wikipedia is.
Yes.
Excellent. So let's talk about the rings.
Oh, yes.
So how thick are these rings? Like when you look at them, they can seem razor thin.
Yeah, if I think, what is it, every 12 years or something like that, the rings of Saturn will be edge on from our perspective on Earth. So you just see this line, and it's very it's very strange to see it like that because you're used to seeing far more detail in those
Yeah.
rings. But they're quite, the rings are quite thin relative to the size of the planet.
Yeah. Yeah, they're like around 100 meters or 100 yards thick, I guess. And there's a couple theories. One of them was that these rings are the remnants of a moon that was destroyed around Saturn, and then the other is that they originated from the solar nebula when Saturn was being formed in the early parts of our solar system formation. But some of the ice in the rings comes from Enceladus's geysers, which we kind of referenced earlier. And yeah, they go edge on about every 13 or so years, just depending on where we are in our orbit, where it is in its orbit. But it takes 27 years for it to go around the sun. So it's exactly, well, not exactly, but it's about halfway through um, that period of time that we'll see them, and then around 13 or so years later, we'll see them again and go edge on. But it just depends on how we're lining up with Saturn, and of course Saturn has a bit of a tilt too. So there's a few other variables that happen, but we'll see them edge on again, I think, in 2025.
Interesting. And one of the other neat things too about the moons, at least some of them that the Cassini mission validated, was that a number of these moons are actually like ringed shepherds. The moons influence the particles that make up the rings around
Oh yeah,
Saturn and
right.
sort of keep them in place and keep some like uniform divisions within the rings. Again, it's a very neat system of how it all comes together to form this beautiful work of art in the solar system.
Yeah, yeah, it's pretty amazing. Anything else to add? That was a good point. Anything else to add on Saturn?
That, yeah, let's move on to what is next one here? Uranus.
Uranus,
Yeah.
seventh from the sun, an ice giant made up of water, ammonia, methane ices. It's also got some rings and moons, and it was discovered on many occasions before being recognized as a planet. In fact, as you know, I'm very interested in early visual astronomy, and both Hipparchus and possibly Ptolemy, way back in the early BCs, actually had it added to their star catalogs,
Wow.
and it appeared in the Almagest. Although they just sort of plotted it as a star, because it is just sort of at that faint star, but naked eye visible level. They did end up plotting it, which is really interesting. I mean, it just shows how exacting they were. Even in those days, that did not escape their attention. So, but it wasn't really known as a planet until Herschel came along and made the official discovery in 1781. But there's several instances of John Flamsteed and Lemonnier observing it, much earlier before that. But Herschel's the one that kind of gets the credit. But it's got this odd tilt to it. It's kind of hard to get your head around the tilt, but they think it was slammed into by a couple objects. I was watching the. Have you watched the season 3 of Cosmos yet with Neil deGrasse Tyson?
No, I haven't.
Which is it's sort of an interesting show. But they do a good explanation of what happened to Uranus in that. They show these two bodies kind of colliding with it, and then because of those collisions, it's set on its edge, so that for 42 years it gets continuous sunlight on one side, followed by 42 years of darkness in the 84 years it takes to go around the sun. Have you observed Uranus before?
Yeah, in my 8-inch Dobsonian many, many years ago, I saw it a few times.
Yeah, I think it's one of those things. Like you track it down, it kind of looks like what sort of like an aquamarine. I'm actually looking at my TAC focuser. The color is not too different from like the the steel color on a Takahashi telescope.
Yeah, like you can definitely pick up that color. I didn't find that challenging at all. One thing I'll say though is that's it. Like there's not much else to see. It's
Yeah,
very small in comparison to any of the other planets that we've talked about.
yeah,
It is almost stellar in appearance. Like it almost looks like a star, except it is larger. Like you can make out a real small disc or circle, and again, that aqua color is
yeah.
apparent.
Yeah, and in like the larger amateur telescopes of like 10 inches or so, people report like limb darkening, and you can see Titania and Oberon, the moons. It is a variety of other moons as well, and a ring system which is not visible from Earth anyway. So, anything else to add to Uranus? These last two are going to be a little bit shorter than the first two because Jupiter and Saturn have such striking features. They're so large and so close, and then Uranus and Neptune are much further away and pretty uniform in appearance.
Yeah, they are, and I think there's two. I think there's two general things that I'll say about Uranus and Neptune that kind of make them intriguing to me, and it's not from a observational standpoint from my telescope. It's that they are so far out. Um, we know, of those two planets, we know the least about them compared to, say, Saturn and Jupiter. We've also sent probes to Saturn and
Yeah,
past Jupiter, which have provided a lot of information and data. But the other thing, you already mentioned the axial tilt of Uranus. So, normally the north is on kind of the top and south is on the bottom, but this whole planet's on its side, which is bizarre.
yeah.
And then when we start talking about Neptune, I think it rotates backwards, if I'm not mistaken.
Yeah, I don't have that in my notes, but yeah, I believe you're right. So Neptune is the eighth, and it'll be our final planet. Of course, I do want to tack on that I'd like to do another one of these podcasts on the other sort of real planets. I think to talk about some of the asteroids and dwarf planets and Kuiper Belt objects are really sufficient. To include in the solar system as well, because they are so large and an important part of it. But it takes about 165 years for Neptune to go around the sun. So I think it's like just completing or whatever its second orbit or halfway through its second orbit since it was discovered in 1821. So it's got a great dark spot that has been observed by the Hubble, and it, incidentally, was actually observed by Galileo, and he drew that on December 1612 and January of 1613. So it's really interesting. It's really unfortunate that he didn't, sort of recognize it for what it was. There's just no way that he would have. But it's funny, like an astronomical discovery, as with science. It's not a discovery if the observer doesn't have the knowledge of what they're looking at, right? So even though he did sketch it, it falls to others to make that claim. So it's sort of confusing on who can lay that claim, though. Like I kind of sent you that story. I don't know if you read through it all.
Yeah, I did. Yeah, it was interesting.
So it's a bit of this back for. I don't think I'm going to read this whole thing though. This was more for like, I guess, just background on it and that. But there were a variety of people, we'll put it that way, that were involved in the discovery. One individual was a mathematician who kind of lobbied for the Berlin Observatory to go and to take to take a look for it. But it kind of seems now that it was one of these sort of debatable things on who, and there seems to be some sort of political overtones into whether it was observers in England or Germany or wherever in who actually discovered the planet. But they think that this planet, just like with Uranus, they think that Uranus and Neptune probably were formed towards the inner part of the solar system, like during the solar nebula phase.
And then just kind of made their way outwards.
Outwardly migrated. They call it the outward migration, which isn't really well understood. But in order for them to have the constituent components that they have with all that water ice, like water ice just wouldn't have occurred in such quantities out, in an orbit that takes 165 years to go around the sun. So there's 14 known moons. Can you name one moon of Neptune?
I cannot.
It's Triton. Now, to
Triton,
be
right?
Titan, right? And it's great because you can think like Neptune is the god of the sea, right? And then he carries isn't it the Triton that he carries?
I think so.
Sounds
right.
Yeah, that 3 pound. Wouldn't be my weapon of choice, but I guess it may do in the early Grecian times. So, yeah, and it takes a long time to go around. And Triton was actually discovered only 17 days after the discovery of Neptune by William Lassell. So, unlike any other large planetary moon in the solar system, Triton has a retrograde orbit around Neptune, and it's tidally locked. So there's some rings around Neptune as well, but you can't see them from Earth. They're only a Hubble Space Telescope or large, Keck-based telescope. You would need like the very, very largest. So with that, I think we'll end our tour of the solar system with one sort of final comment on Neptune. We've gone all the way from the inner solar system to the last official planet in the solar system. But if you look at Neptune through a telescope, you'll kind of see what Earth would look like if you were looking back at the Earth from one of the other planets. And Neptune kind of looks like a pale blue dot, very much maybe as Earth might appear if you were to look at it. So it's kind of neat to kind of get to the end of the solar system and then say, hey, if you look back, this is kind of what Earth would look like if you go to take a look. Have you seen Neptune through your telescope, Shane?
Yep. With that same 8-inch Dobsonian that I saw Uranus. And Neptune certainly has that blue look to it. Uranus, a little more aqua, maybe a little tougher to perceive that color sometimes, but
yeah,
Neptune is very apparent. It's very neat.
Yeah, I did take a long look at it one night through a 10-inch. We put a 10-inch. It was on a really big equatorial mount out in the fields, and we watched it for an evening. And it was pretty neat. Like you could definitely see the color, and we didn't see any clouds. Some people have like sketched out some pretty vague looking clouds on it. But it has that sort of very much like ocean blue, like what you might think of as like a nice beach color. It's kind of neat.
Yeah, another interesting note about Neptune that I'll just throw in real quick here is the kind of official discovery when it happened. I believe that Neptune was the first planet to be theorized to exist before officially being discovered.
Right.
There was math that was done to indicate there should be another planet beyond Uranus. And then astronomers from all over the world tried to validate or verify that. And then Leverrier, I guess, if I'm saying that right, was he the discoverer, or did he do the...
Yeah, it's
math,
I think he's the one that kind of in the end has received the credit.
Right.
Leverrier.
Yeah. So that's kind of interesting because there's also some theories out there that there's a planet 9 that exists even beyond Neptune. And is that, the Kuiper belt? Is that, was it a planet that never really formed? There's all sorts of interesting speculation about that too.
Yeah, that's from a few years ago now, I think. And they declare that they had sort of mathematically discovered this planet based on, all these other tidal interactions and gravitational forces. Yet it's never been observed, right? It's that same
Mhm.
kind of situation. It's a little bit of the chicken and the egg. Like, what are you observing? Well, they're observing that there's something out there that's causing these things, these gravitational perturbations. Yet nobody has sort of quote unquote like visually seen it or photographed it or whatever. But that's just one other sort of a piece of evidence towards declaring something in existence, I suppose, because you could, in essence, find something that looks like a planet, but then maybe it's hollow. It doesn't really have much gravitation. Could be a giant comet or something that's just going to sort of melt away really quick. I mean, there could be a lot of caveats, but they're saying that this is not those type of things. So I like it. It's sort of philosophical in a way. Like, when does it come into existence? Just when it's theoretically proven, or when it's visually observed one way or another. So I kind of like that aspect of it. It's pretty neat. So what do you think,
Yeah.
Shane?
Uh, I just like to look at what I can see. So I'll let the astronomers figure out Planet Nine.
Seeing is believing.
There we go.
Cool. Anything else to add on our tour of the planets, the 8 planets of our solar system?
No, that's it. I'm looking forward to observing a number of them over the coming months.
Yeah, cool. All right. Well, thanks so much. And thanks for everybody for listening.